And let's begin. Hey, everybody. Welcome to this session of the Orlando Data Professionals Meetup Group. My name is Alex Merced. I'm going to be today's presenter, but I'm also the organizer of the Orlando Data Professionals Meetup Group. So if you're watching this, whether you're watching this live today as we present this session, or you watch this after the fact on YouTube, we're always looking for speakers for the Orlando Data Professionals Meetup. We generally do these meetups mostly virtual. So basically, again, doesn't matter where you're at. If you'd like to speak on any event, on anything regarding data engineering, data science, data analytics, and feel free to reach out to me on LinkedIn, or you can message me. LinkedIn is probably the best place. And then we can get you to be a speaker here at the Orlando Data Professionals Meetup. Always like to, help bring great content to the Orlando data community. Okay, and again, people from everywhere are welcome to speak and welcome to attend, because we just want to bring out great data content. But today I will be presenter in our second session of this meetup group, and today we'll be doing a talk that I've been doing for the last bit. Actually, I performed this in Seattle last week, and then in New York City the week before that. Okay, and basically the talk is ZeroETL and Virtual Data Marts, the cutting edge of lakehouse architecture. So there's a lot of little words there, right? ZeroETL, Virtual Data Marts, lakehouse architecture. By the time of this topic, not only will we know what these words mean, but we'll kind of see and wrap it all together to really paint you for like where's data engineering is now and where data engineering can be when you adopt, the right tools. Again, my name is Alex Merced. I'm a developer advocate at Dremio. And basically what I do is I talk, I write, I basically advocate for data lakehouse architecture, which is a very particular way of sort of architecting your data infrastructure. And basically in my time, I've worked for many companies in the web and data space, including GenEd Systems, Crossfield Digital, Campus Guard, General Assembly. I'm the co-author of an upcoming O'Reilly book, Apache Iceberg, The Definitive Guide. And I've spoken at many events like Data Day Texas, which I'll be speaking at again in January, OSAConf, P99Conf, Data Council. I was at Past Data Summit last week. And I'll be speaking at the Move Data Summit in, I think, next week. So constantly, finding places to talk about data. Okay, I just love technology as a whole. I do a lot of content around not just data, but web development and development as a whole. And I also do several podcasts in the data space. And speaking of the Apache Iceberg Definitive Guidebook, again, Apache Iceberg being a very big topic in the data engineering space. And this is going to be the book on that topic by O'Reilly, the big publishers in technology. Now you can get yourself a free copy, early release copy of this book by scanning that QR code right there, where basically you can get an early copy of the book and kind of, start learning about what is Apache Iceberg, what are table formats, what is this whole data lakehouse thing, and all the stuff. Many of the topics I will touch upon today. Also, again, I am the host of several podcasts, including Gnarly Data Waves, which is our weekly broadcast at Dremio, and then several other podcasts that I do on my own in the grand scheme of things, Data Nation, Select Star from Data Lake, where I talk about data engineering, data analytics, data science, particularly, especially at a high level of understanding sort of like the trends, the topics, the concepts, and all of those can be found on Spotify and iTunes. But now let's begin with our featured presentation. Okay. Basically, what I want to talk about first off is like, where are we nowadays when it comes to data engineering? Okay. And, assuming wide audience, let's talk about what I mean when I say data engineering. Okay. So bottom line is that we have data analysts who are, creating data reports and dashboards that help us derive insights for different businesses. Okay. We have data scientists who basically build out AI and ML models in order to, predict things and be able to create like things like our favorite things like ChatGPT and Google Bard and all these LLM models, all these kinds of tools. But for them to do all that, they need to receive the data, and that's where the data engineer comes in. Okay, and data engineering is all about getting the data from where it was, in operational systems and log data, sensor data, and get it into systems primed for analytics. So we have all our data sources. Okay, SaaS apps, on-prem applications, custom apps, wherever the data currently is being generated inside of different databases for those kind of operational systems. Now the data engineer now needs to go get that data and then move that data to somewhere where we can begin working with it. Typically, the first stop is a data lake. So think of a data lake as just a big dumping ground of all your data. Doesn't matter what kind of data it is, whether it is structured data, so data that you could easily think of as rows and columns, kind of like an Excel spreadsheet, or whether it is unstructured data like audio, emails, things like that. All that data is going to have to land in a data lake. And we're going to have to write code. If I'm the data engineer, I'm going to generally write some sort of code, some sort of algorithms that are going to take the data from the source, extract that data from the source, maybe transform it, mold it to what we need it to be, and then land it or load it into our destination, okay, what we refer to as ETL pipelines. But those ETL pipelines can be kind of complicated because there's like different sources, different data, different types of transformations we need to make. And then oftentimes you don't just land the data in the data lake. Oftentimes you'll land what's called the raw version of the data. Then you'll take that and make another copy that's transformed a little bit, and then maybe take that copy, transform that a little bit, and each of these is like another pipeline that depends on the previous pipelines running. Okay, so imagine like if you have several different pipes in your plumbing system at home, and if one pipe breaks, everything kind of falls apart and water gets everywhere. Okay, in this case, data gets everywhere. Okay, but the story doesn't end there, because typically a lot of our analytics aren't necessarily done directly on the data lake. Oftentimes, we're going to have special databases that are built for analytics, oftentimes referred to as data warehouses. Okay, and these data warehouse platforms are sort of built to make it really easy to access the data for data analysts and data scientists and be able to do the kind of work they need to work with it. You know, whether those data warehouses exist on-prem, so they're actually physically in the office, or they're in the cloud using a cloud vendor like AWS or Azure. And oftentimes within these data warehouses, you'll have little mini data warehouses called data marts. Okay, so we basically we're going to do another set of ETL pipelines. So that means a whole bunch of code to move all that data once again into the data warehouse. And then we're going to have to create even more pipelines to move all that data in the data warehouse into the individual data marts for each business line. So here's like the data mart for accounting, here's a data mart for whoever, and so forth and so forth. Okay, now then from there, the client, our data scientists, our data analysts will then use the data to create BI dashboards, custom applications, data visualizations, and so forth. But again, sometimes we'll work with that data from our data lake. Okay, so sometimes some of that data the clients are consuming are going to be directly from the data lake. But you can see here, that's a lot of code you have to write. You're talking about all these different pipelines, and then all these pipelines are basically assuming that every pipeline that happened before worked out correctly. Okay, and then you have to figure out, okay, well, not only do you have to make sure all of these work, but I have to be able to monitor them so they still work. So you have to set up monitoring systems, observability systems, and then every time you have to make a change, you have to make a change to like all the pipelines, all the different pipelines in the chain. It can get really cumbersome. Okay, and that means the more pipelines that have to run, you're going to start seeing more potential for problems. The longer it takes from data to get from point A to point Z, because it has to go through all these different pipelines. There's all sorts of different sort of catches with that. Okay, so what's the problem? Okay, well, one broken pipeline requires tedious backfilling, because what happens is that all the data ends up being wrong. And now the thing is that depending on how your system is set up, you might have to go correct that data manually. So you have to figure out, hey, which data is the bad data, and then figure out what is the good data, and basically rebuild data sets and do what's referred to as backfilling, which can be really tedious and time consuming. So that's one problem. Okay, and then you have all your consumers at the end of the line, your data scientists, your data analysts, your business users, who are now kind of upset because the data is not getting there as soon as they need it. Okay, the data is not correct, so they're making bad business decisions based on incorrect data. Okay, so the data engineer life can be really stressful when things don't go right, and it's really easy for things to go wrong when you have these huge layers of manual pipelines that you manually write, and basically have to, every time you change them, you got to change a bunch of pipelines, and then you have to redeploy them and test them, and this whole chain goes over and over and ends up kind of eating up your life. And you're in a situation where basically you're just focusing on maintaining what is, and not finding the time to kind of expand and go deeper and whatnot. Okay, from projects that keep further expanding what you have. And it's not just like the tediousness of it all, but it's also expensive for your company. Okay. Like they're paying for the storage. So every time you make a copy of the data, that's more storage costs. Okay. Every time a pipeline runs, that's compute. You're paying for that compute power. Because especially if you're operating from the cloud, you're paying for how long those computers are running to process all this code. So the more pipelines, the more compute, the more cost. You have network and egress costs. Okay. Cloud vendors like AWS, Azure, they oftentimes don't charge you to bring data into their system, but they charge you when data leaves their system. And these are referred to as egress costs. And this is oftentimes where people get really kind of caught off guard when they're using like data warehouses, because they'll take that data from the data lake, okay, which is oftentimes a cloud vendor like AWS, Azure, where they're storing that data, and then they'll move it into a data warehouse, something like a Snowflake, and then they're like, okay, well, I knew I was going to pay for compute to do that. I knew I was going to have to pay for more storage to do that, but they didn't expect the egress cost. They didn't expect that they're going to get all these extra charges because they moved data out of AWS and then get hit with a much larger bill than they expected. Okay, so you have that. Okay, you have the lost productivity, the time you're spending just fixing your existing pipelines and making everything that already exists work is a time you're not building other things. Okay, also just the time it takes for all those pipelines to run and get the data where it needs to be. So you're not using the data. You know, it's like, for example, if you have like a house where the bathroom, the shower's on the complete opposite side of where the water setup is. Well, then when you want to turn on the hot water, well, the water heater's on the other side of the house. So you have to wait for the water heater to heat up the water for that hot water to go through all the pipes until your shower's finally actually putting out hot water. Okay, think of that with like data pipelines, how long you have to wait for that data to get there. So the closer, the less pipelines there are, the closer the data is to its final usage, the faster it's going to get there. Regulatory fees. Okay, we got to deal with like all sorts of laws and rules and all these things. Okay, and the cost of all that really add up. Okay, and especially when you're thinking like finance. Like I used to train people in finance regarding like financial regulations and which records you got to keep for 3 years, which records you got to keep for 6 years, what kind of details have to be on those records. And if you missed some of that, you got hit with huge fees. Okay, so same thing. You want to make sure you have that information. If you're talking about like AI and ML, there's certain models that are being, you're building different AI models. And every time you copy that data, the underlying data may just drift away from the fundamental model that you are working off of. So you don't necessarily want that either. And then also just the cost of bad data. Like, okay, basically, let's say everything's working, but there's some sort of mistake in the data because there was some sort of mistake in the code. And now you have bad data and people are making decisions based on bad data. What's the cost of those bad decisions that don't, you end up investing in one product when you should have been investing in a different product, or marketing in one venue versus a different venue or something like that. So there's a lot of costs to, all the potential problems. There's a lot of potential problems. It's really easy because there's so many pipelines, there's so many different pipelines you have to write. It's very easy for any mistake to appear at any layer. And you have all these different costs that come along the way. So how do we improve this? And this is where like the Dremio Lakehouse platform. So again, I work for Dremio. And basically this is sort of like where the platform sort of really kind of comes in and helps. So you still have all your data sources. Okay, so again, if you were to sort of adopt this approach, this is what we refer to as ZeroETL. So again, if ETL means moving the data, okay, and you having to manually write the code to move the data, ZeroETL would be not doing that. Okay, and if data marts were these physical mini databases you built in your data warehouse, a virtual data mart would be, not doing that without having to physically copy the data. Okay, so we would take our data sources, and what you would do is you would connect it to everything would operate from the data lakehouse. So you would land the data still in the data lake. Okay, AWS, Azure, that physical place where you're going to land the data, where however format you're going to land it in, and then Dremio will allow you to access all that data and query all that data directly from the data lake. So there's no need to move it again to a data warehouse. So you eliminate those, and you don't necessarily even need to do the transformation. So notice it becomes, instead of ETL, it becomes EL. You don't focus on doing all little changes to the data. When you move it, you just move the data. Okay, you move the data, you land it in the data lake, and then you connect Dremio to your data lake, and then everything else is done virtually. Now, what do I mean by that? Okay, what we mean is that going forward, you define the changes of your data in the logic of how you ask Dremio to query the data. Okay, And then essentially that's how you deliver to clients. So essentially what will happen is that clients, your data scientists, your data analysts will have access to Dremio, and they'll see all the data sets with all the changes and transformations, but those transformations aren't physical copies. Instead, they're logic. They're basically an SQL query that describes how the data should be shown to that person. Okay. And this is referred to as virtualization. Okay. So again, and there's different levels of virtualization here. Well, meaning that you're making it feel like you made copies of the data. You're making it seem like all the data is in one place when really the data's maybe in many different sources. Some of it's on your data lake, some of it could be in other places. It may seem like there's all these different versions of the data, but they're all really different views, different ways of logically viewing the data, but you're still looking at that original data source. Okay, and the beauty of that is if you don't have to physically move it, there's less likely that you're going to taint the data or distort the data in that movement because you're not moving the data. Okay, the data is just kind of its an original form. Okay, so with Dremio, if you use that Dremio as a little like platform that you put on top of your data lake to kind of give it that data warehouse feel, which is referred to as a data lake house, when you basically try to turn your data lake into a data warehouse, thus the term data lake house. Okay, what you're doing is you get a couple benefits. Dremio allows for federated data. What does that mean? It means you don't have to move all your data to the data lake. It can connect directly to your databases. If you have an existing data warehouse, it can connect that. So let's say we're starting with Dremio today, you don't have to move any data anywhere. You can work with the data where it is. Okay, oftentimes referred to, so again, ZeroETL, because you're not moving the data to start using it. Okay. Then Dremio has a semantic layer where you can organize that data and say, okay, hey, this data, I need people to be able to look at it this way, this way, this way, and using SQL, structured query language, to describe the different ways people should be able to view the data and create layers of different views on the data in the same way we would create like a data mart. But again, back in the data warehouse data mart, we would actually create physical copies in different versions of the data for different use cases. Here, we're just creating different logical views. And then we can still organize those and say, hey, these are the views for accounting. These are the views for marketing. These are we can still model that data and organize that data in the semantic layer in the same way we would organize those data marts. Okay. And then usually what would happen is that there are other platforms that say, hey, how about you virtualize your data? You don't make copies of it. We just connect directly to it. But oftentimes what happens in those other platforms is that as your scale grows and you start having more and more data, it just doesn't perform. Okay, it's really hard to get that performance when you're grabbing data from so many different places. Okay, and this is where Dremio really is different. Dremio has a special feature called Dremio Reflections. Okay, and what it does is that instead of you building your own pipelines to make copies of the data for optimal performance here, optimal performance there, all you do is you say, hey, which things, so you have this big chain of views that you've modeled your warehouse, and you can say, hey, this view right here, I need this to be faster, and at the flip of a switch, under the hood, Dremio will do what needs to be done to make that faster. So instead of you having to manually make a pipeline where mistakes can happen and then you have to figure out how to keep it in sync, you abstract that away. Dremio will kind of do all that automatically for you under the hood and creating sort of like a optimized representation of that data to speed up those queries. Okay, making this type of virtualization where for the data engineer, it feels like they're connecting all their disparate data in one place without having to make copies, making it easier for the user because the user just feels like they're interacting with the data directly where it is. Okay, data abstract, and then Dremio will just abstract away all the stuff that has to happen in between to make that work at the flip of a switch. You just literally say, okay, hey, I need this piece to be faster. You flip a switch, the reflection switch, and technically, basically, it's almost like a pipeline on demand. Okay, basically, there is a pipeline that kind of under the hood, but you don't have to make it. You don't have to manage it. It's all automated. Okay, for different use cases, and we'll get more in detail about that. But it allows for this sort of virtualization to be practical at large scale. Okay, not just for ad hoc queries. The occasional search like other platforms. You can actually make this sort of the center of your data gravity thanks to that breakthrough. Okay, so again, what's the benefits of this approach? Okay, so what's the benefits of me like I get it, Alex. Okay, like okay, I don't have to move the data. I get it. I don't have to make all these extra copies for every different version manually. Like, why is that good? Okay, I mean, again, less pipelines, less backfilling, less things that break. Okay, the less code you have to write, the less code you have to debug. Okay, and the data just gets where it needs to be sooner. Instead of from A to Z, it's A to C. Okay, the number of steps to get to your end users is quicker, and they get the data faster. And then those data consumers, if they're getting that fast, fresh, consistent data, okay, because all of this is just being abstracted away, they're going to be able to build their reports faster, build their ML models faster. Everyone's going to be able to get what they need to make better decisions quicker, okay, build new products faster, and do what they need to do to move the business forward. So not only are you going to also, on top of everything else, save money, because when you don't move data, that's less storage. If you're not copying the data, if you're not doing all this movement of data, that's less compute, okay, that you have to pay for. And if you're not moving data out of the data lake, you're not paying any of those egress fees. Okay, and then if the data remains fresh, you're getting it faster, and basically you comply with regulations because you're not going to have a bunch of inconsistent copies that might cause regulatory issues. Okay, no data drift, and basically better insights. So basically, you're going to get business value in those better insights faster. Okay, so the business can make more money, but the business also saves money because they're not paying for everything they'd have to be paying for if they were doing it sort of the traditional data engineering way. Okay, so there's a lot of benefit to this. Okay, I mean, a lot of companies will find that just this oftentimes ends up paying for itself. Okay, and then not only does it pay for itself, but as you see later on, like Dremio has a lot of things that makes using data easier, especially for non-technical people. So that way non-technical people can take better use of the data. And that means more people at the company can participate in getting value out of the data of the company, which again provides value. And that's referred to as data democratization, when you're able to make that data more accessible to more people. So that way people can reach for data when they need it. Okay. Now, how does Dremio make this all possible at scale? I kind of already mentioned this. I kind of released the secret sauce, but in general, the theme here is high performance virtualization. Okay, the idea is that oftentimes the barrier with other platforms and making virtualization sort of the way you do your data has oftentimes been performance. Okay, if I'm grabbing data from 10 different places, okay, even if that makes my life easier because I can use them all from one place, can it perform well enough to meet all my use cases? Okay, and this is where sort of Dremio really is revolutionary. It not only makes it easy to use your data anywhere, but it makes it performant to use your data anywhere. And that is the key distinction. That is what makes Dremio different sort of than other platforms that try to do the same thing. But how does it do that? Again, I mentioned one thing, reflections, which I'm going to revisit again. But even if you didn't use reflections, Dremio is a really fast tool for querying and searching through data. And there's reasons for that. Okay, one is Apache Arrow. Okay, Apache Arrow is an open source in-memory format. I'll explain what that means. But fun fact is that Apache Arrow is in its earliest stages before it was Apache Arrow, was actually started out as the in-memory format for Dremio. Okay, so basically this thing that's kind of taken over the data industry and how to do things fast started at Dremio. And essentially what it is just when you load data, so if I read your data wherever you have your data, okay, I have to load that data into a computer's memory to start doing work on it. Okay, how I represent that data in memory can affect how fast I can do certain things. Okay, so Arrow structures that data in a very standard way, creates a standard way to represent that data in memory that's optimal for analytical type work. Okay, and the idea is that the standard is really good, not just because it gives you that columnar analytics focused way of representing the data, but the idea is that as more people adopt Arrow and more tools adopt Arrow, data can travel between tools using that same format, which means if everyone's using the same format, you don't have to convert. Okay, so think about it this way. Imagine I go buy a bike from Europe. Okay, the measurements are going to be different. Okay, so for the time it's going to take me to build that bike is going to be slower because I have to constantly be converting things from metric to standard. So that conversion, oftentimes referred to as serialization or deserialization, when we're talking about sort of technical processes, that costs time. Okay, so the less times we have to convert things back and forth, the faster we can do things. And Arrow creates a standard format for data systems to not have to be doing this conversion over and over again. Then there's like Apache Calcite, another tool that Dremio leverages, which is leveraged by many tools that do sort of SQL querying, but this is what enables like taking an SQL statement, structured query language, and breaking it up into pieces, so that way a tool like Dremio can then process it. Okay, allows for there to be cost-based optimization, so that way you can take your SQL query and turn it into a better one, a faster one. Okay, and other types of optimization, saying, hey, so basically enabling the developers at Dremio to really build in a lot of optimizations to the SQL that you write when you query things with Dremio. Okay. On top of that, you have reflections. Now, reflections generally fall into two main categories. Like there's some other categories of reflections, but there's two main categories. There are raw reflections and there are aggregate reflections. Okay, the raw reflections, essentially, typically what you would do, okay, again, absent Dremio, absent this ZeroETL world, you would probably use something called a materialized view if I had a certain table. So like, for example, let's say this is the old way, right? I have my data sources. I take my data sources, I move them to my data lakes, and then I move them into my data warehouse. And in my data warehouse, I split it up into a bunch of different little marts. And then each mart, I start, basically modeling my data. Okay. And then maybe say like this copy of the data here isn't fast enough. So let's say this is like a view on the data that just isn't performing the way I wanted to perform. I would create what's called a materialized view, like literally a copy of the results. Okay, making a physical copy of the results of a particular query. So that way, next time I need to query that data, I don't need to actually process it. Problem is, the data is constantly changing. So those materialized views become out of sync. So now I have to create pipelines to keep the materialized view in sync and think about how to handle that. And technically, that materialized view becomes a separate table. So then my analysts, my data scientists, need to know the name of that other table. So if I have table A and I create a materialized view on it that we call A2, well, if I don't remember that I need to query A2, not A, well, I'm still going to end up with a slow query. I only get the benefit if I query A2. Okay, these are the things that Dremio sort of solves for. When you create, so same story, but the Dremio way, okay, instead of me moving the data into here, I didn't move the data anywhere. So in this case, I have a Postgres database. I have a MySQL database that I connect directly to Dremio. So I'm working with the data directly where it was. And then from there, I'm creating views on Dremio semantic layer and modeling my data like I would in the Mart. So you see here, no ETL happens here, no data movement. But then I'll say, hey, I joined these two tables, like there's a Postgres table and a MySQL table. I join these two tables together. And sometimes when running that query, it takes a little longer than I'd like. What I can do is I can turn on reflections. I just literally flip a switch in the Dremio UI. I just click a button. And what Dremio under the hood does is going to create a copy of the result in the same way that materialized view did. Okay, but it's like a very optimized copy. And two, there is no table A2. Your users would still query table A, and Dremio knows that you have a reflection on table A, and then we'll swap that out. Okay, so basically, from the point of view of your end users, they're still just working with those raw tables directly in those databases, and Dremio's handling the swapping of like, hey, we have something to make this particular query faster. Dremio will also handle the updating of that. So as the data changes in your Postgres and MySQL, Dremio will update that reflection, and then again swap it out when it's relevant for a particular query to make it faster. So in this case, basically, what happens, a lot of things that make it hard to use materialized views are no longer there. You don't have to worry about syncing it anymore. Your analysts don't have to be worrying about juggling all these different names for different things to query. They just query the thing they were going to query anyways. Okay, and it just makes life a lot easier, and you're getting that performance. Okay, and you're getting that virtualized feel because everyone's just working from the point of view of just interacting with the data. They're just interacting with the data where it lies. They're not seeing what Dremio is doing under the hood to make it fast. Okay, so again, you're managing less movement of data. I'm not saying there's zero movement of data, but it's less, but there's no data movement that you have to manage. And that's sort of the benefit of this. Okay, that allows you to focus on how I model the data. So how do I organize it instead of just focusing on like the technical, like how do I copy it? Where do I put the copy? How do I update the copy? How do I keep all these copies in sync? You don't have to think about that. You can think about how do I organize the different versions of how we look at the data to meet my business needs, and let Dremio handle like the performance side of it. The other big issue that we run into, like with data pipelines, is you create things called BI extracts and cubes. Now, what's this? When you do BI dashboards, so when you create like those little visualizations like charts and whatnot for people to make decisions based on, they're typically based on aggregates, right? You're thinking, okay, hey, how many customers do I have this month? How many customers do I have this month? What is the average sale? These are what's referred to as aggregate measures, where you're taking many data points, many sales, and averaging them out. Many customers and figuring out, hey, what is the total number of customers? You're aggregating data, and you build BI dashboards based on this aggregated data. But running those calculations every time someone brings up the dashboard can get expensive and take time. So what people have done in the past is they create BI extracts and cubes. These are just terms for pre-computing these numbers. So you would pre-compute. So in the same way you would materialize the result of a query with a materialized view, what you're doing is you are making a copy of the results of aggregations. So you're making a copy of, you're pre-averaging certain numbers, you're pre-figuring out what the max number is, you're pre-figuring out what the total number of a certain number is, or the sum. So you're pre-calculating these aggregations to build dashboards based on. But again, just like materialized views, I have to figure out how to keep them updated because the data changes. So then I have to keep updating them manually. And then I have to make sure the analysts know that don't make your dashboard on the table, make the dashboard on the cube or the extract. So you have all that same sort of like, there's a little extra work to make it work. Okay. So again, they're static. They don't change. They don't automatically update. You have to be the one who updates them, manages that. Okay. And then oftentimes when you don't delete the old copies because you're too busy just keeping it up to date. So you end up having this cost of all the storage. It just keeps building up unless you maintain it yourself. And sometimes they can be so large they cause memory issues. Okay. Dremio handles all of that. So when you turn on aggregate reflections in Dremio, it's handling this side of the story. Okay. Instead of pre-computing the results of a standard row by row query, it's going to basically materialize the aggregations of that table. Okay, so it's going to keep it up to date. So it's always going to kind of up to date as the table changes. As the data changes, the reflection updates. Dremio takes care of that. Okay, it's automatically going to maintain so that way you don't have like 1,000 copies of the same reflection every time it updates it. So it's going to delete those old versions for you. Okay, it's doing all of this for you, so you don't have to write any manual code or pipelines. You just flip a switch. And it's flexible. It's actually going to structure how it holds that data in a way to avoid a lot of those memory issues. And Dremio's engine knows how to process that data so that way you're not running into the same kind of memory issues and out of memory issues you would run into with like BI extracts and cubes. Okay, so bottom line is a lot of the pain on the engineering side of having to create pipelines for all these little like performance use cases become no longer something you have to worry as much because you can just flip a switch on the Dremio UI to speed those bits up. You still have to think about how you organize your data. Modeling is always going to be the biggest challenge when it comes to engineering because you want to make sure your data is modeled in a way that covers your use cases. But this allows you to spend more time thinking about your models and less time thinking about the technical performance of things because Dremio will take that part off the table. Okay. Now, another cool aspect of sort of like how Dremio is an MPP system. Now, what does MPP mean? It stands for multiple or massively parallel processing. Okay, and that means it takes basically the idea it's built to work with very big sets of data sets. And the way it does that is by breaking up the work across many computers. Okay, so things like Hadoop, Apache Spark, these are all MPP systems. They're designed for doing big amounts of work by splitting up the work. Okay, so typically these systems always have some sort of master computer. In this case, this is referred to as the Dremio coordinator node. And then they split up the work among many worker nodes, okay, who all take a piece of the work, okay, to process that query across, your giant sets of data. Now, what Dremio does, it uses this technology called the columnar cloud cache. Now, remember I mentioned all those egress costs every time data leaves S3 or every time you have to request data from S3, those costs can build up. Okay, now Dremio is going to speed up your queries and reduce those costs using this columnar cloud cache. What it does is that on each worker node, there's a cache. Okay, so basically as you process queries, Dremio is going to notice that certain queries you run a lot or certain data sets you access a lot. And what it's going to do, it's going to cache those data sets or portions of those data sets on the different worker nodes. So that way, as more queries come in, you're not going back to your cloud storage to get the data every time, because the data will already be on the worker node, allowing it to process the query faster. But without having to request the data, you save the cost of the request. So your cloud costs go down and your query performance goes up. Okay, so the idea, faster queries, save money. That's generally going to be the theme here. Like everything Dremio does to make things faster, oftentimes also coincides with making things cheaper. Okay, so if you go to like dremio.com/customers, you can hear a lot of stories of how people reduce their costs, sped up things. It's pretty insane what happens once you implement this. And again, it's not something like, the great thing about it is that it's incrementally adoptable. It's not like something where you have to like change everything you're doing overnight. Like it's, you can think of like, hey, I have this one thing that we're about to do. Let's try it out with Dremio, see how it goes, and then you can like add more use cases as you successfully, like it's very flexible. It's, you can use it a little bit, you can use it a lot, and as I'll mention later on, you can pretty much use it for free to get started. It's not like, which is pretty good cost savings. But anyways, also when you're using like Dremio, you also have auto scaling. Now this story is a little bit different depending on which way you use Dremio. Like Dremio has two different deployment models. So you might deploy it on your own infrastructure. Okay, so you do what's referred to as like an on-prem or software deployment. Now in that case, generally you would typically, or you should do that using Kubernetes. Okay, and then generally with Kubernetes, you have these scripts called Helm charts that help you spin up what you're doing pretty quickly. The Helm charts for Dremio actually have auto scaling built in, so you can actually set up rules so that way it spins up additional worker nodes or spins down worker nodes as needed, depending on what your workloads are. If you're using Dremio Cloud, so that's like the cloud you just sign up online and now you have Dremio version, that one allows you, instead what you do is you provision clusters, like groups of computers that run queries, and you can actually set it up where it'll automatically add clusters as you need them and then shut them down when you don't. This way you're never paying, because another problem you see with like a lot of systems is that you have to provision all sorts of compute. I mean, like actually have computers running all the time, and then you're having to pay for that, even if they're not processing a query, and that gets expensive. Here you can kind of spin up when you need it to, spin down when you don't. So that way you only pay for what you need if doing that. So again, the benefit is you're getting rid of a lot of that manual work where a lot of the little issues come in. And again, building out all those pipelines and then fixing all the issues with those pipelines ends up taking a lot of the mind share and time when it comes to your data infrastructure, instead of focusing on things like that, like modeling and sort of like what data should be there and the quality of the data. You're oftentimes just running around trying to patch and fix things. Okay, by getting rid of those layers of pipelines and moving more towards a ZeroETL world where you're moving the data less and taking advantage of virtual data marts. So again, modeling your data, not physically with lots of copies, but through sort of logical views on the data. Okay, you end up moving that data less and you reduce a lot of those frictions. Okay, using Dremio semantic layer, we do the virtual data mart. And again, it's high performance using things like columnar cloud cache, data reflections, a lot of these things that we talked about. And because of that, Dremio can reduce a lot of your compute, storage, and network costs, because you're not storing as much, you're not running compute as much, and you're not storing as much, but still being able to do all this at high performance. Okay, do this at scale. So you're able to do virtualization at scale. Not just be able to virtualize. There's other platforms that can let you virtualize, but Dremio allows you to virtualize at scale because it takes care of those performance bottlenecks. That's what makes it worth it. Okay, and then again, you have unlimited concurrency, as we just mentioned. You can scale things up and down. But again, at the end of the day, it's less work because you have less pipelines you have to kind of maintain. It's going to cost you less, and it's easier to use, not just for the data engineer organizing all of this, but also for the data analyst, because all the data they need is accessible in one place. They're not juggling 50 different names because reflections are transparent. They don't have to be like, oh, there's version A and version B, and I need to query version B for this particular purpose. Dremio will swap out reflections when they make sense. Dremio will figure all that stuff out. They just say, hey, I need to query, the sales table. I'm going to do this query. And then Dremio will swap out the right version of the sales table to give them the most performant query possible. So that way they can just focus on what's the question that they're asking instead of having to think about, hey, I want to ask this question. What are the right data sets I need? It just makes it easier on both ends to be able to focus on the core purpose of all this, which is to generate business value and discover insights. Cool. Now, moving forward, this to kind of show you, like, okay, let's say you were just to go set up Dremio today, like what would be your like next steps? Okay, first thing you would do is you would, connect your data to Dremio. You would first deploy your Dremio. Again, you could either do it through software using something like Kubernetes, or you could deploy it through the cloud, where you just literally go to dremio.com and sign up, and you have Dremio. You would just connect your own, cloud infrastructure account, which would be either AWS, or next month will be, or next month or so, we're going to be releasing a Azure version. So basically, you'll be able to use Azure as well if you're an Azure user. But you just connect your data sources, and you can connect databases. So let's say I'm connecting like a Postgres or MySQL database directly to Dremio. Let's say I'm uploading files. Okay, I might have some Excel files, I might have some CSV files, and I can upload them directly to Dremio and run analytics on them. I might have data that already exists in the data warehouse because maybe you're a Snowflake user, or you may have data in Delta Lake tables because you're a Databricks user. You'll be able to connect all that data and connect it all to Dremio as well. Okay. And a really neat thing, though, is if you land the data specifically in iceberg tables. So some data, like the data you really want to be like super fresh and consistent all the time, ideal world, what you'd want to do is you would probably do an ETL pipeline for that. So maybe I'd use like Spark or Flink, land that data somewhere as an iceberg table. But that would be the only ETL I'd need to do, because when the data is in this iceberg format, okay, it's one of these open formats. I've done other talks on that. So, and then I've also written the book on iceberg, or was one of the authors of the book on iceberg. So you saw that earlier. So I'll defer to that for all the details. But if you land the data on iceberg, what Dremio can do is that usually when Dremio updates reflections, it has to like recalculate, what the result of that query is, or recalculate those aggregations, and then kind of swap it out. When the underlying source is an iceberg table, it's actually able to calculate what's the change. So instead of having to rebuild the reflection from scratch, it can actually just do smaller updates, which are quicker. So that way, all your reflections are updated much faster, like almost real time. So it's the minute the underlying data changes, the reflections are updated, which allows not only for reflections to continue providing you the performance that I've mentioned, but also to stay fresh. So if you're to have data that changes very, very frequently, like every few seconds, or multiple times a second, when you're landing the data in iceberg, all your reflections will reflect that for maximum like data consistency. And again, when I say data consistency, is making sure that everywhere you look at that data, it's giving you the same information. Okay, if I look at 10 copies of the data, all 10 copies should give me the same information, or it's not consistent. Okay, and again, I can then, once I connect all my data, I will use Dremio semantic layer to model the data, and I can organize it into like folders with data sets in them. Okay, so I can have a marketing folder, a finance folder, a sales folder, in the same way I would organize data marts in a data warehouse. Okay, where basically, again, I have all these, generally split it up by business line. And then, you might would do what's called a medallion architecture, where you generally split up that data into 3 categories: bronze, which is your raw data before you really did any changes to it. And then you might, do some combining of data sets, do some joins, what's referred to as denormalization, and put that in like the silver bucket. Then you might do some more extra cleanup and additional work, and you put that in like gold. Okay. And then, you'll have those data sets. Okay. And then people will know, okay, if I want to look at the raw data, I can go look in bronze. If I want to look at the cleanest sort of refined version of the data, it's in gold. But at the end of the day, you're not making data copies. These are views. So what you're doing is you're using SQL to say, hey, look at the data this way. And that SQL code allows Dremio to sort of repackage the data the way that you want it to be seen, without making a physical copy of the data. But again, to speed that up, I can always turn on reflections. So in this case, I have my raw data, the raw version of my data. I did some cleaning and some validation. And then here I have my silver data. And then I turned on reflections on that level of the data. So now that speeds up any queries on the silver data, and will also speed up queries on the gold data, because the gold data is based on the silver data. So in this case, I didn't have to make a pipeline from here to here to here. I just literally flipped the switch on this level, and it sped everything down from that level down. Because the cool thing about reflections is that they're not just for that one view. They speed up any other views that are based on that view. So in that case, since the gold data sets are based on the silver data sets, the reflections on silver will also benefit any queries on the gold data. So that's where you start really getting the bang for your buck. You're getting the sort of like the physical sort of optimization going on under the hood, but it's reaching across multiple queries, more queries than normally would, and you're getting a much more broader benefit from that. And at the same time, you're modeling your data, okay, and everyone can go examine the data on Dremio in this nice sort of organized way, okay. So now, how would I do that? How do I do all this modeling? You could just do it straight from the Dremio UI. You could just write SQL straight from the Dremio UI. It's actually really easy. It has like a nice little SQL editor. If you ever use any kind of code editor, you're gonna feel very at home with it. Where you can look up functions and all that kind of stuff. It's great. You could send everything in Dremio can be done through SQL, not just like querying, but like creating data sets, connecting data, granting access to the data. Everything can be done in SQL. So Dremio is like everything, SQL, all the things. Okay, and so you can send that SQL via the REST API. So if you're writing like a Python script, you could basically send SQL to Dremio and get data back, or control Dremio and like grant a user access to data, all from using the REST API. We also have a dbt integration. Dbt is a tool that a lot of data engineers love to use, because what it does, it allows you to express sort of what your data should look like, express what your data models are, and then you can use templating syntax to express, well, here's this table, and then this table or this data set is based on this data set. So then that way, when you run your dbt jobs, then it creates all your versions of your data. Because again, usually you have like this version of the data, and then based on that version of the data, you create this version, and then based on that version, you create this version again, from like bronze to silver to gold. Well, you can describe what those data sets are, and then when dbt runs all your work, because of the way you wrote your SQL, it knows which data sets are based on what. So it'll run everything in the right order for you. So it makes it where you have to like not think as hard about which SQL do I run first. You just write the SQL, and if it knows, hey, this SQL refers to this data set, then it knows that data set needs to happen first before this one happens. So you can write your dbt model, and you can literally automate the generation of your entire those virtual data marts straight from dbt as one way to do it. Okay, and again, you can also send SQL to Dremio via JDBC, ODBC, Aeroflight. They're all different ways to deliver Dremio the SQL to generate all these things. Okay, and again, you can do everything with SQL: create folders, create views, create reflections, grant permissions, run queries. All of it can be done with SQL. That's the beauty of Dremio, because everything can be done through SQL, and SQL is generally something that, I would say probably almost all data people know. It basically really allows for that, what's referred to as data democratization. So allows everybody to get involved in all aspects of the data, because it gives you this really easy form. For example, if I'm trying to control who has access to the data, okay, using SQL statements, I can control who has access to what folder, what each individual data set. I can control who has access to what columns of the data. So that way, if a certain user accesses the data, they don't see certain columns that might have like social security numbers or email addresses, referred to as PII, personally identifiable information. That's an issue with certain regulatory rules. Okay. Maybe there's certain rows I don't want users to see. So I can create row-based controls that control which rows users see. I have all these sort of controls that allow you to be, one, meet your company's internal security rules, but also meet any external security rules you have for like regulatory purposes, whatnot. So again, you're able to connect all your data in one place in the Dremio platform, no matter where the data is, and you can control who has access to it. Okay, those are some of the biggest challenges when it comes to engineering data, because oftentimes you have your data in 10 different places, and each place has their own way of controlling who accesses it. And that gets really frustrating, having to figure out, hey, Bob needs to access the data. Now I need to create an account for Bob on 10 different places and create those access rules in 10 different places. I can just do it all in Dremio, one place. And I can do it easily through SQL, and I can even automate some of that, because I can always just write a Python script that just automatically does all the right SQL commands, sends them over to Dremio. Okay, so basically, once I connect the data to Dremio, I model my virtual data mart. So I create all the versions of the data that I need. And then I grant access to that data to whoever needs the data. And then we just use the data. And one thing you could do is you could be now analysts and just start using the data. So they could be using it for BI dashboards. So for a data set that's going to be used for a BI dashboard, I could just turn on aggregate reflections, as we mentioned earlier. And now when I connect that data to Tableau, Hex, Superset, Power BI, Looker, Dremio works for pretty much any and all BI tools, has really deep integrations with like Tableau and Power BI. Okay, you can really get that full benefit, and you're going to get that really super fast performance. Okay, because that's oftentimes what happens. Either you have a dashboard that has really inconsistent data because again you have to go through all those pipelines and create these BI extracts, which are frequently stale, okay, in traditional ways, or you have a fast, or you have a really like slow dashboard because you're crunching on the raw data, and there's nothing there to really speed it up. Well, Dremio doesn't make it where you have to make that choice. You can have fast BI dashboards directly on the raw data because Dremio is managing that aggregation reflection under the hood for you. You can create you can basically bring code your data from Dremio into your notebooks. Okay, again, Dremio has a REST API, it has JDBC, ODBC connections, has an Aeroflite connection. So in your Python notebooks, you can connect to that data and then pull that in there for analytics. Like here's some examples. Here's an example of using ODBC, JDBC to pull the data into your Python notebook or into Python code in general. Here's an example of using PyArrow. Okay, there's different ways just to pull that data directly from Dremio. So it's easy to do your AI and ML work from your favorite notebook tool. Okay, you can create data applications. So maybe I want to create a custom application for people to be able to access data, because maybe you're a business who wants to give certain partners or certain customers access to certain data. So you're creating an application for them to consume. Okay, Dremio can allow you to unify all that data that your company has on your customers across different places, like different data lakes, different databases, different data warehouses, unify it and deliver it to your application. Okay, so in this case right here, this is just like a Python application that literally all it does is just basically runs a query and then makes a chart. So essentially, like, this is like the fast API application, and this is the HTML it sends back that just renders a chart with the data from that query. So you can do all that. Okay, Dremio makes it really easy to just unify everything, bring it together, and do that high virtualization at scale to make data easier, faster, and more open. Again, that open piece is the most important piece, because when you democratize your data, you make that data easier to use for everyone in your company, you're going to get a lot more value out of it. Again, my name is Alex Merced. I talk a lot about data. Again, we have Gnarly Data Waves, In the Grand Schema of Things, Data Nation, Select Star from Data Lake. These are all podcasts that I am the host of. So I highly recommend subscribing to those on Spotify, iTunes, so that way you can hear me talk about other topics in the data space, whether they like what are data lakes, table formats, denormalization, normalization. And thanks for coming to this talk. And yeah, what I'm going to do now is I'm going to open it up to questions. And again, in the future, if any of you guys ever have a topic that you'd like to talk about here at the Orlando Data Professionals Meetup Group, just shoot me an email. Just message me on LinkedIn. Just look up Alex Merced on LinkedIn. I'm not hard to find, and I'm more than glad to arrange that for you. But with that, let's open it up to questions. If anyone has any questions, feel free to just come off mute and ask away.
Hey, Alex, this is Siva. Thanks for the talk. This is very good. I know you were talking about Azure integrations. So what kind of an integration with Azure is coming up within Dremio? Is it like have an ability to integrate with the storage piece of it? I mean, or Synapse, or is that what is coming out kind of a thing?
Yeah. So to answer that question, basically, there's basically, there's two deployment models for Dremio. There's the software deployment. So already on Dremio software, you can already use Azure. So if you're deploying your own Dremio, you can use Azure as where you host your Dremio instance, and you can already connect Synapse, you can connect ADLS, you can connect SQL Server. So you can connect all these data sources that you have within the Azure ecosystem and unify all that data in one place and work with it all in one place, which can be really useful for not only just taking all the data you have in Azure, but if you have data that's outside of Azure, connecting it with the data you have in Azure. So yeah, you can already do that just with Dremio software. Now with Dremio Cloud next month, I think, well, Target, I think it was slated for next month, is going to be, I think, the release of the public preview for Azure Cloud. So that means Dremio Cloud, the cloud deployment, will now be able to be deployed on Azure directly. So that would be the cloud you would connect to your account, and you'll be able to actually host your Dremio instance directly in your own virtual private cloud on Azure, and still connect to all those other sources within the Azure ecosystem as well. So basically, you can already pretty much do everything with Azure with Dremio software. It's more being able to do it with Dremio Cloud that's going to change next month, because up till then, Dremio Cloud's been sort of an AWS mainly thing. But again, and another note that I forgot to mention is that both of these are things you can start with for free. So a Dremio Cloud account is something that's for free. The only cost you would have using Dremio Cloud would be any compute instances. So that'd be basically your AWS or Azure bill that you'd get for any compute that you spin up. So it would be, but there'd be no bill with Dremio itself. And then if you want to spin up your own infrastructure using like the Kubernetes Helm chart, that's also free. That's referred to as like the Dremio Community Edition. And there's lots of companies that actually have used like Dremio Community Edition or a free Dremio Cloud account and have used them for free for like a year longer, sometimes a couple of years. And then what they do is that once they kind of hit to that point where, because usually what you do is when you upgrade, you get like support, you get you're going to get some security features, but not everyone needs that right away. So the point is like you can start using Dremio now. It doesn't necessarily have to, and, it doesn't cost you anything. So it's worth looking into whether it's you want that as part of your data world. Does that answer your question, Siva, about the Azure piece?
Yeah. No, it does. So if I don't prefer to use cloud, is software available on the marketplace? I can pull it and use it on Azure. Is that the case already today?
Yep, I think that's I think Dremio is on the Azure marketplace. It's definitely on the AWS marketplace, and I'm pretty sure it's on the Azure marketplace as well. If not, I think it might have just been recent. I think it's been there,
Okay, cool.
but it's definitely on there. And if not, there's also the K8 Helm chart, and you can deploy it right through Azure through Kubernetes.
Okay, cool, perfect. Thank you.
No problem. Cool.
Hi, Alex. Yeah, I had a question on the transformation. If I used Dremio like a couple of years ago, and I see everything is defined. Like you don't go through a process; you just define like views in SQL. But I don't know if that is enough because I need transformations that is difficult to do in SQL, like cleaning up the data and running a program, and how that fits into that model.
I mean, some of that may be able to be done with Dremio, like in a sense, like Dremio's added a lot in the way of SQL functions over the years. So it should have a lot more SQL functionality than it did a couple years ago. And also has the ability to do DML on iceberg tables. So if you do need to do like actually physically transform, like removing certain data points, you can do that out of iceberg tables. But also like that sort of ZeroETL that it's oftentimes meant for like last mile ETL approach. So for example, like some of the validations that you're talking about and some of the cleanup you were talking about, you may still want to do before you land the data in the data lake. So basically, but the idea is you don't have to do every transformation before you land it. So you can still have the data fairly raw, and then maybe you do some minor transformations and then save the rest of it to be done through SQL views and a lot of the more like modeling and data curation that happen on the view side, and just save the actual physical transformations for cleanup work.
Okay, thanks. Also, you supported the HDFS because what I had was a clustering on-prem, no?
Yep,
On
and
Kubernetes.
that's a great point. I'm surprised I didn't mention that. That yes, Dremio supports any storage layer. So basically, you can connect to HDFS, so that's the Hadoop file system. You can connect to AWS S3, ADLS, Minio. Basically, it's pretty agnostic as far as what the data source is. So you can connect. So Dremio is one of the few tools that can connect to on-prem and cloud at the same time. So it's very popular, and particularly with people who have on-prem data lakes as a really modern tool to really speed up and refine their on-prem data lakes. That's a really popular use case.
Yeah, I see it was very useful when you have different people and everyone has different access to the views and to provide solutions to give every user that doesn't need to see all the data, just to see part of the data. But
No,
I
agreed, because you don't have to give them access to everything. You just give them access to. Everyone always starts off with like access to the zero things, unless you're admin, and then you grant them to what they need, which makes it really nice. Because anyways, the other thing I want to mention is that also we do have some other features coming up. Like we have this thing called our Dremio Arctic catalog, which includes many data lakehouse management features. Essentially, what it allows you to do is actually, we were talking about like data quality and like how would you handle that in Dremio? Well, with Apache Iceberg tables, what you can do using Dremio Arctic is you can create a branch. So I'd be able to like actually isolate the ingestion work and isolate a lot of that data quality work on a branch, and then like publish those changes when I feel like I'm ready to do that. And that's going to be something that, well, you can already do with Dremio Arctic. And the cool thing about it is that it's a catalog that you can bring to other engines. So I could take that Dremio Arctic catalog, use it in Spark, create that branch, do all my isolation work. I mean, do all my ingestion work, do all my data quality checks, and then if all my data quality checks pass, then run the merge. But then all those branches are also visible to Dremio, and you can then query that data there. So like I'll probably do another talk on that in the coming months, more on the data ops, data as code side. But that's another cool thing that we have sort of coming up. Like it's a little bit more forward looking. So, it definitely enables some really cool patterns. And there's some other technologies that are coming out from some other companies that are going to complement that really well. That's really going to result in sort of this future where basically you have a much more sort of structured way of just sort of ingesting the code.
Another question, support real-time streaming?
Oh, yes. Okay. So support for real-time streaming, that right now, basically it's, you read it from the data lake or you read it from wherever the data source is. So it's just depending on whether that source is real-time. But soon what we're going to have is we'll have a Kafka connector. So you'll actually be able to like basically connect to a Kafka stream directly and basically land that into an Iceberg table through Dremio. I think that's how it's supposed to work. Like it should come out in, I don't want to give an exact date, but it's on the near term roadmap.
Yeah, that's cool. It's
Yeah, no, I'm really
evaluating that a couple of years ago, but it was that part of the real time. So like the reflections that optimized the speed.
And now reflections can update real time. So basically, if you land the data in Iceberg and then all the reflections are based on Iceberg data, everything stays pretty consistent.
Yeah, what's the issue is how often you update the reflections.
Yeah, because like basically, if it's a non-Iceberg table, it can be like something like depending on how frequently that data is updated, it's tough to get to that really short like multi-second latency. But yeah, soon that'll be pretty interesting because you'll be able to like have the data come in Kafka, so come in real time into an Iceberg table, and then all the reflections based on it will update essentially real time, and you'll get that'll be really, really. The more I think about it now, I'm starting to get really excited. Yeah, the future looks good.
Those Iceberg tables are the same Iceberg tables in Databricks.
Well, so Databricks typically uses Delta Lake tables, which Dremio can also read. Snowflake has Iceberg features. Like there's lots of different engines that have built Iceberg. That's why we tend to support Iceberg very heavily, because it's generally been the more industry-wide accepted standard. There's definitely like more robust support for Apache Iceberg across more tools than any of the other two formats, Delta Lake and Hoodie. Delta Lake has really robust support in Databricks, and then some support everywhere else. But we can read Delta Lake tables off Dremio, and we do support Delta Lake and Iceberg, but we have full, like, really robust support for Iceberg. Like everything is very Iceberg centric in the platform.
So I'm not familiar with Apache Iceberg. Could you?
Sure. Actually, what I'm going to do is
I'm going to go back to
Apache Iceberg, basically Apache Iceberg, Delta Lake, and Hoodie, what they all are what's called a data lake table format. Okay, and what basically a data lake table format is essentially like a metadata layer you put on top of like all your Parquet files that allows an engine like Dremio to look at that table as all the like 1,000 Parquet files and treat it as like one table, and basically allows tools to interact with your data lake more like a database instead of treating it like a storage of files.
Oh, I see. Thank you.
Yep, and then here you can get the free copy of the book on Iceberg that we're writing at this QR code here. Cool. Any other questions?
No, thank you.
Okay, well, oh, thought I heard a voice. Nope. Okay, well, again, all of you guys, thank you so much for coming and attending, and this has been a great time. Feel free to reach out anytime you have any questions on anything. Also, hopefully you guys all join the Orlando Data Professionals Meetup. We'll have other talks on other topics. Again, if you ever want to speak at the Orlando Data Professionals Meetup, just reach out to me. I'm more than glad to arrange it. And again, thank you very much. And I look forward to staying in touch with everybody. And yeah, thank you very much.
Thank you.